evening, everyone. Good evening. Yeah, my name is Mofesola Babalola. I'm a site reliability engineer. I work and live in Berlin, and I have been doing Istio and talking about Istio. I've been doing Istio now for maybe 6, 7 years, and I've been talking about Istio for over 1 year. I had like lots and lots of knowledge about Istio deployment from days of when Istio was still running at sidecars until when it became available in the ambient mesh. And then last year I decided, with the help of a colleague in the industry, that it was time to start, talking to people and sharing the idea. And yeah, that's what I'm doing now. I think this is maybe my sixth or seventh time of talking about something related to Istio. My personal time, I ski, I rollerblade, I go hiking, bicycles, I do other fun stuff that my income can allow me to do. So over to you,
Okay,
Hannah.
okay. Good afternoon. This is my first time in Zurich, so I'm really excited to see what the city has to offer. I live in Berlin. We came from Berlin, but okay, we live in Berlin, but we came from New York just at KCD conference. So we're really excited to be here to talk about this topic. And I'm an engineering manager, so not really as experienced as Mofesola, but I love to speak at conferences. I like to share knowledge, and I like to also hear back from people who come to the conference. So we look forward to your questions. Feel free to ask us questions about our topic or anything else. A bit about me. Well, I love to ride my bicycle. I'm getting new hobbies like how to skate. So yeah, really excited about this topic. So over to you.
All right, so today we are going to be talking about. Can you hear me?
Yeah.
Okay, good. So we're going to be talking about solving microservices chaos and the service mesh solving microservices chaos and when you really need one. And I will do like a brief intro and then she'll talk about the agenda. But one thing I have found out over the years is people have, so we know exactly how we started working with microservices. So maybe 20 years ago, we had mono repos and monoliths, and that was the style of software development then. And then people broke it down and said, hey, we can have the transaction service, we can have another service talking to different API endpoints, and we could have this service talking to users. So we ended up with, you know, a mesh of services. And we have things that come onto these services. We need services to talk to themselves. We have common denominators across all the services. And a lot of people deploy their containers on Kubernetes. How many people use Kubernetes here by show of hands? Use Kubernetes? Okay, how many people use other container orchestrating systems like ECS by show of hands? Okay, not a lot of people. Yeah, so we deploy to this system, and the systems are complex enough. And then people have said, hey, you know what? I understand that we need the service mesh in some way, but should we introduce another layer of complexity? Kubernetes is complex. It has the control plane, the data plane, kube DNS, kube proxy, HCD, and you have to keep learning about different things. Should we then introduce this level of complexity? So we're going to talk about like all of this and how to make that decision if it applies to you.
Okay, yeah. So as I said, we share about the agenda so that you understand some of the processes that we're going to talk about. So at the first beginning, we'll talk about the microservice stacks, which Mofesola has given a few intro about it. Then go deep into what Istio is, and then talk about the three pillars that will actually show us connecting to a real world benchmark. So a test that Mofesola had set up on his own, and we can see the data and how this actually works out for us. So for the microservice stacks, is there any way we can talk about this in a way that in a team setting it would make sense?
Yes, so like I was talking about this earlier, we have different services. The promise is you're going to be able to deploy your services independently, and we see how those problems came up. I I have dealt with like monoliths in times past where you want to make a small change to a transaction service somewhere and you have to rebuild the entire app. the entire CI pipeline runs for like 30 minutes or 1 hour or 2 hours because it's testing different things, and you have to deploy this new service. To roll back is even a bigger pain. So the promise is that you can, make small incremental changes to your to different part of your apps or different parts and services that make up the totality of your app every day. You can scale each service individually. So if you discover that people are calling like transaction service a lot, and the user service is not being used that much, of course, because people just log in once they get their token, then they deal with transaction in some way. You want to be able to scale transaction services independently of user service. So this running microservices helps you to do that. You can use different languages and frameworks. So if I'm not tied to a monolith, your team could be deploying something in Python, and another team does something in Rust, another team does something in Node.js, depending on your skill and how you want to scale. And you have like small focus teams, like 2 3 people designing this, and another set of like people deploying something else, of course, and faster release cycles. But the problem that we actually face, the reality is, there are many things that we want to do, especially when it comes to reliability. We want to do retry logic, for example. I have seen many apps that you have retry logic, or if you get 503 error, try again for 3 seconds, back off, exponential back offs. You put all these things into the logic of your app. So you have like 20 different microservices. You have to write this logic in different ways. Maybe some people have architectural review sessions where people talk about how they do these things, but most of the time people just take their initiative. We need exponential backup. How am I going to do it? Yeah, I'm going to just write something that makes sense to me, or use a different framework or something. Faulty injection, circuit breaking, rate limiting. Everybody just does what feels good to them. We need mTLS. Security comes and says we need mTLS. How exactly are you going to do that? People say, oh yeah, we can deploy some framework, but this app is written in Python. How does it talk to this other one? Okay, we'll figure something else out. And I tell people this, right? Every time I talk about Istio, I said when you get to the scale that you need a service mesh, one of 2 things are likely to happen. The first one is either you inadvertently build a badly managed service mesh, or you actually deploy something that works, like Linkerd, like Istio, or the rest of them.
Yeah, so I see that the problem here actually, as for me as a team lead, is in my team we don't have experience in network, for example, setting up something in infrastructure, but now we have to run these microservices in a way that is really effective and efficient. So what you're trying to sell to me is that Istio is gonna resolve this solution for us?
Yes, exactly.
Okay.
One thing I've discovered is that while it's not a bad thing, many software engineers have become like part-time network engineers. You understand
Okay.
how things operate under the hood, which I'm very happy about. But appreciating this knowledge means that you say, hey, I don't think this is the right way to do things. I'm writing, so for example, I'm writing, how many people know what HTTP 429 is? 429? Yeah, okay. So you return a 429 if you're rate limiting a service or a person, right? And someone says, oh, how am I going to rate limit this person? By IP, how many requests per second should I do, or how many requests per minute? And all of this, I have to bake it into my application. Okay, another client comes and says, we're going to pay for the infrastructure, but we need a bigger limit. And then someone has to bake this into the app, or write something else, or a service, or write a backend service that allows me to manually set this. And it just creates a lot of complexity and chaos. And people have to understand, or software engineers have to not only understand, but have to deal with all these things under the hood. This solves the problem by making sure that this problem is offloaded to the infra layer, where it's much more visible. So I'm not looking into your app to see exactly what how you're doing exponential backoff, how you're doing rate limiting, how you're doing fault injection, how you're doing traffic mirroring, how you're doing mTLS, or how you're doing even JWT, which most of us are familiar with. I can see all of this from the infra layer, and it is common to all the apps. Whatever is running on the back end doesn't matter, even if it's Python, it's Rust, it's Node.js. We have a common framework everybody uses. You have YAML configuration, a couple of lines that creates virtual services, that creates all the other Istio configuration that we need. So yeah, talking about the microservices stacks, I've talked about the reliability tags. So thinking about things like retry logic, timeout, circuit breaking, you hard code all of these things in every service in different languages, and it's very inconsistent.
I think the big one here is actually the security tax, because for in the end, in the team, you want to know, are we still maintaining security and
Yeah,
everything? Yeah.
so, exactly. So like many times when we are thinking about designing things, I'm very big on, oh, I need to make this work. When I started like software engineering, I used to write PHP with PHP frameworks some 20 years ago. And my biggest goal was to, okay, I want to make sure that when a user signs up, they get an OTP as SMS. Once I can close that logic, it's good to me. As I started to advance in my career, I started saying, oh, yeah, people could do SQL injection, there could be cross-site request forgery and all of that. So I need to find a way to block that. And many of the frameworks that I started to use had that, baked in. So I didn't have to write SQL filters or like SQL injection removers. I used frameworks for all of these things. And it's the same thing with security today. If you write your app, it works well, and someone says, hey, for every service within your cluster to talk to the other service, it needs to go through HBone or mTLS. It's going to be like, why do we need to have this overkill? So why you might think about reliability tags as something embedded in your system. I mean, I want to call an API. If it fails, I want to make sure that I retry a couple of times before I tell my own user that this has failed, which makes sense. But the question will be, why do I have to have mTLS, and why do I have to deal with this complexity to get mTLS up and running? So, what is a service mesh and introducing Istio? A service mesh has two parts. You have the data plane proxy, and then you have the control plane. And the control plane is the guy that pushes all the config, makes sure that you actually have a working mesh. And then the data plane proxy, when you're using sidecar, is the part that has like sidecar proxies and all this additional configuration. Interestingly, I would like to at some point talk about the ambient mesh and the sidecar versus ambient mode. So one big thing, and again, this is about like talking to your teams and talking to people about why exactly Istio is as mature to the point wherein it's easy to deploy and easy to manage. I used to work at Wayfair, and we heavily depended on uh, Istio, and I was part of a small team that managed Istio. We had the service mesh team, and one of the biggest pain points was actually upgrading Istio. So Istio injected sidecar proxies into every pod that had Istio enabled using the admission controllers available in Kubernetes. So what this meant is if I want to upgrade Istio to a new version, I upgrade the control plane. I make sure that a new revision is available. When it's available and I've tested it and everything is working, I have to do a rollout restart of every pod that has Istio enabled. So that it kicks the old proxy out and introduces the new proxy. And this was a chaotic mess. It never looked good on a dashboard because during that period, you had like some failures that happened when you're cycling pods and all of that. Another big disadvantage to the sidecar proxy is that you had a lot of idle envoy proxies. So you budget envoy proxies and they're just running. And many of us understand how we actually scale applications behind load balancers in services that we use. For every pod that you scale, for every replica set, you have a sidecar proxy inside of it. While it's not processing requests, you are not only having the pod sitting idle, you're having the sidecar proxy sitting idle. And you can't scale the application independently of the envoy proxy. With the ambient mode, you have many choices. First of all, you have the choice to decide how you do security, right? So I can deploy Istio. Now, Istio has multiple components. It has Istio D, which is the control plane. You have the Z tunnel, zero trust tunnel, which runs as a daemon set, so you don't have it per workload anymore. You have it per node. You have Istio CNI, which does all the routing and configuration around networking, which is also a daemon set. And with these three components, you can actually have mTLS security out of the box without any big configuration. And that's all at layer 4, and it is lightning fast. Now you think about, I want to do like fault injection, circuit breaking, I want to do path-based routing, the kind of things that you could do with your ALB on Amazon. You then need to introduce an envoy proxy, which is the waypoint proxy, and you can decide, number one, how and when each of these apps talks to waypoint proxy. You can also decide uh, how to scale the waypoint proxy, which is a big win. So instead of scaling your apps where you have traffic, you are scaling the waypoint proxy and saying, okay, yeah, we know how HPA works, so it uses HPA. I'm so sorry, I'm just assuming that we know. Do
Yeah,
we know what
I was
HPA
going to
is?
ask. Maybe we should check in the room if
Yeah,
people have
sorry.
set up Istio already, and if they are actually running Istio in production.
Sorry, by show of
Anyone?
hands, how many people run Istio on production here? Okay, a couple of
So yeah,
hands.
maybe you need to.
Yeah, so okay, I'll try to slow it down a little bit. How many people know what HPA is, or horizontal pod autoscaler? Okay, yeah, exactly. So that's what I'm talking about in with using the waypoint proxy. So you could scale the waypoint proxy separately from your apps with this, and there's so many other advantages, but I'm going to keep it at this for now. Okay, so reliability, you can just look at this. I've talked about many of these things. Before, you can see the before and after, right? So before you have to write this logic into all the apps, like, oh, if an HTTP error is returned, retry, how many times do I want to retry, exponential backoff and all of that. With uh, when you introduce Istio, you just have like a couple of config lines. Timeout, same thing, 2 lines. Circuit breaker, same thing, a couple of lines. I know a lot of people do like what's it called, rate limiting, having like Redis or Redis Sentinel running somewhere, and then tracking who has made the call, how many calls they've made, and all of that. It still does all of this for you out of the box without you having to think about it.
Yeah, what would be the biggest sell on this pillar of reliability to a team that has already been running things reliably?
So it's something that we've talked about earlier on. The biggest sell is the fact that you are not hard coding in multiple languages in different ways. Like there are many apps in the team I currently work with that I have to figure out, using um, Claude or something, where exactly the code that does like retries is written within the app. You would run through everything, you can't figure it out. We have like very large Nginx proxies that do like different kinds of routing, and for you to know how traffic flows from the ALB until it gets to the service that it needs to get to, you have to like do a lot of hops and figure out what was written in Lua, what the Nginx config looks like, how this traffic hops from one hop to the other. So the biggest sell is actually transparency,
Okay.
and uniformity across the board when you have your mesh.
So if my service is running in Python, another service in a different language, this combines them.
Yeah, so you
Okay.
don't have to. This is very agnostic to your service. In
Okay.
fact, many times when you set up a service like Istio, your backend service doesn't really understand what's going on. Istio thinks about like the config you've written and decides itself whether this backend service should receive traffic, how it should receive traffic, or what response it should give. So, for example, if someone is supposed to talk to a backend service and you're supposed to talk to me in mTLS, and I've set up the peer authentication as strict instead of like permissive, it still blocks the connection if it's not mTLS. Your backend service doesn't know. It doesn't have to change any configuration. Everything is done within the mesh.
Okay. What's about the next pillar
Okay.
that we talked about?
So
Observability.
observability, which is also a very big one to a lot of people. You want to do like tracing, and I know a lot of people write like we use like system D, and we push logs to an agent or a daemon running within your workspace. But with Istio, you can actually have your golden signals directly from the mesh. Now, if you need advanced telemetry, for example, if you need to understand how queries are being called and all of that, definitely you still need to introduce an agent within your app. But then if you need like just your golden signals, your latency, what path is being called, what error is being returned, all of this is available for free once you onboard Istio. And what this means is that you introduce a new app. You're not even thinking about like, oh yeah, we need observability. I need to put like my Datadog API keys or whatever hotel configuration. Once you've configured the mesh to actually ship out things, you add the service to the mesh. It has visibility immediately into that, and you can get your golden signals out of the mesh.
Okay.
And the final pillar, which is security, we talked about this. How many people know what mTLS is by show of hands? Oh, nice. Okay. So initially we think about like man-in-middle attacks. So we have the client authenticating to, trying to verify the authenticity of the server, right? But the client could also be fake. So we came up with mTLS, wherein the client authenticates the server also authenticates the client. Once both of them feel like they're comfortable with each other, then they allow traffic to flow. And this has been such a big win because most of the time when people think about security, we think about like north-south security. We don't think too much about east-west because if you get into my Kubernetes cluster, I make you go through VPN encryption. There's a kubectl CASAT. There's so many layers of security before you can get into the cluster. So I feel once you get into the cluster, things are safe, right? But this is not always the case. So things like a service like mTLS actually helps you. And installing Istio, this is one of the things that you get easily and freely out of the box.
Okay. So I think we could go to the benchmarks. Out we're running out of time.
Yeah.
But yeah.
Okay, so real world benchmarks. So initially, when we ran the sidecar proxy, one of the advantages is the ops between services. So you have pod A trying to talk to pod B, but what happens is pod A thinks it's talking to pod B, but it's talking through its sidecar proxy or the envoy proxy to pod B's envoy proxy to pod B. So you have like a one-to-one. Introducing the ambient mesh, we introduced a couple of other components. So you have zTunnel, which operates on layer 4. And if I want to talk from pod A to pod B, I talk to zTunnel on my node that I'm hosted in. It routes the traffic to zTunnel on the node of the service I want to talk to, and then goes to the service. But then, if what I'm doing has any layer 7 components, say I'm doing like rate limiting, or it has to talk to waypoint proxy for whatever reason, we now have multiple hops. So I talk to my zTunnel talks to my waypoint proxy and talks to the waypoint proxy of the other service. So you have more hops. And then I did like some benchmarks. I have the code I used to run this on my GitHub. So if you're interested, you can get that after the talk. But generally, you see exactly what happens with ambient mesh on L4. If all you needed was security, you have very, very low latency. So one of the things that people complain about is if I introduce the service mesh to my environment, is that not just like more CPU, more latency, and all of that? But many times you see that the advantages you get, and if you're just introducing security, is a lot. And one of the big things about this, when I was running this, it didn't actually tell the story I wanted it to tell initially. So I wanted a story wherein ambient mesh on L4 and ambient mesh on L7 was insanely and significantly faster than the traditional sidecar. And while I explained the reason why ambient L7 has a higher latency, when you look at the P99 values, you have more jitter when it comes to running traditional sidecar than the ambient mesh. So you still have a lot of stability, even though with the waypoint proxy, you introduce more latency than the traditional sidecar.
Okay. So I think we already covered this a bit in the beginning.
Yeah.
When you should deploy a service mesh. But I think for the key takeaways, what we'd like you to leave the room knowing or understanding is that the microservice stacks is actually real. And when you think of those three pillars as your focus points, then you're able to make the decision right away if it's something that is feasible for you in your team. I think, yeah, we've run out of time, but if there's any other questions, we can wrap up. Thank you for listening.
All right. Thank you for listening.
Yeah.